All right, Math students, 7 students, this is your Chapter 10 review. Your test is tomorrow. I will walk you step by step through each of these problems. If you need to correct what's on your review sheet, please do so, and that will help you better prepare for your test. That is tomorrow. Now, just a disclaimer, I am doing this at home, so if you hear a very loud boxer bark or a very high-pitched cockapoo voice, that is my dog, so bear with me. Number 1, choosing a blue marble. So there are 6 blue, 4 red, and 2 green marbles in here. Even though you can't see the colors, I listed out over here what they are. And that is a total of 12 total marbles. So since you're finding the probability, you need probability notation. So P of blue is how many blue marbles? There are 6 out of 12. And that simplified is 1/2. Choosing a green marble, once again, finding probability, therefore you need probability notation. Out of 12 marbles, there are 2 green ones, so that simplifies to 1/6. And not choosing red, so P not red is out of 12, how many are not red? Were those 4 reds, that means there's 8 that are not red, and that simplifies to not 3, but 2/3. All right, numbers 4, 5, 6, and 7. Tossing 2 tails. So this is experimental probability. So this is I conducted an experiment, and this is the data that I got from my experiment. So tossing 2 tails, once again, finding probability, you need probability notation. Okay, so I tossed this dime 24 times, and I got 2 tails 5 times right here. Okay, so that's 5 out of 24, and that cannot be simplified. Tossing 1 head and 1 tail, so head and tail. Out of 24, I tossed 1 head and 1 tail 15 times. So that is 15 out of 24, and that simplifies to 5/8. Not tossing 2 heads, so P not 2 heads. Okay, so I didn't toss 2 heads here, and I didn't toss 2 heads here. So 15 plus 5 is 20 out of 24, and that simplifies to, if I divide by 2, that's 10 over 12. So this simplifies to 5/6. And the last one, tossing all heads or all tails. My chart went away. So all heads is 4, all tails is 5. Together that makes 9. So P all heads or tails. 5 plus 4 is 9 out of 24, and that simplifies 3/8. And that was experimental probability. Number 8, a factory produces 90 pairs of designer jeans. An inspector randomly chooses 6 pairs. Hold on, phone call. All right, sorry about that. So an inspector randomly chooses 6 pairs of jeans and 1 is defective. So what is the experimental probability? Here is my experiment that I conducted, that a pair of jeans will be defective. So the probability of defective is 1 out of 6. Okay, so now how many of the 90 pairs of jeans would you expect? So using this probability of 1/6, how many would you expect to be defective? So if it's 1/6 out of 90, how many would I expect? And then you can just do cross multiplication. So 6x equals 90. Divide both sides by 6. And you get x is equal to 15 pairs. So I would expect, using this probability, that 15 pairs of jeans are going to be defective. Number 9 and number 10. On these two, you are using the fundamental counting principle, so you have to count up the number of ways of each of these and use multiplication. So styles, we have short sleeve, long sleeve, and sweatshirt, that's 3, and sizes, small, medium, large, and extra large, that is 1, 2, 3, 4. So 3 times 4, there are 12 outcomes. For location, gym, park, beach, that's 3. Activities, 1, 2, 3, 4, 5, 6, so 3 times 6 is 18 outcomes. 11, 12, and 13, this is independent probability, but it is also compounds. We need to find both things that are happening. So probability of getting a 4 is 1 out of 6, and probability of an even number on a dice is 3 out of 6. So when multiple things are happening, you multiply their probability. So probability of 4 and even is 1/6 times 3/6, which is 3 over 36, which simplifies to 1 over 12. Rolling a 3 and then a 3. So probability of getting a 3 the first time, 1 out of 6. Probability of getting a 3 the second time is 1 out of 6. Multiple things are happening. You multiply their probabilities, and you get 1/6 times 1/6, which is 1 over 36. And probability of a number less than 1. There are no numbers on a dice less than 1, so that's 0 out of 6. And probability of a number less than 2, there is one number 1, on a dice less than 2. When multiple things are happening, you can multiply their probabilities. So 0 times 6 over 1 times 6 is 0 over 36, which simplifies to 0. 14, this is dependent probability. So the cooler contains 10 grape juice bottles and 15 cranberry juice bottles. You randomly choose 2. What is the probability that both are cranberry juice? So for the first time that I pick cranberry, there are 15 cranberry juices in the cooler out of 25. Okay, but the second time I pick cranberry, one of those cranberry juices is gone. So there are only 24 bottles in the cooler, and only 14 of them are cranberry because one was picked the first time. Okay, so probability of cranberry, when multiple things are happening, you need to multiply their probabilities. So 15 over 25 times 14 over 24, and I do not have this one memorized. So 15 times 14 is 210. 25 times 24, and there's the boxer, is 600. And that simplifies to 7 over 20. And number 15, you flip a coin to roll a number cube. This is independent compound probability. So what is the probability that you flip heads and a number less than 3? So the probability of heads is 1/2. And the probability of less than 3, the numbers that are less than 3 are 1 and 2. So that is 2 out of 6. When multiple things are happening, you multiply their probabilities. And 1/2 times 2/6 is 2 out of 12, which simplifies to 1/6. And 16, which sample is better for making a prediction? A random sample of 10 customers leaving a store or a random sample of 100? You always want more customers if you can. So sample B, because 100 people will give you a better estimate than 10 people. A better estimate. And last one, number 17. You want to know the number of students in your school that have a January birthday. So my population is the students in the school. What I'm testing is having a January birthday. So I survey the students in my math class. That is my sample. Okay, 3 students have a January birthday and 32 do not. So I conclude that 8.6% of the students in my entire school will have a January birthday. This is a invalid invalid situation, because if you want to test the number of students in your school and you only ask your math class, not everyone is involved in making the decision. So that is invalid. So not everyone is involved in making the decision. Okay, and when something is invalid, you cannot make this prediction of 8.6% of students have a January birthday. You can only make predictions when your claim is valid. And that is it. If you have any additional questions, please, please, please do not hesitate to email me tonight. And I think you should have it, but if not, it is Megan Scott at lindberghschools.ws. And I promise I will be on my email tonight, and I will get back to you as soon as possible. Have a good night.